This is Mr. Beck Does Your Homework. This is Physics Homework 23, questions 15, 16, 17, 18, 19, and 20. I have a little circuit that I have to analyze, and it says find the current in the 5 ohm resistor. So it's starting way down there. So it's probably best to just pick little pieces of this circuit and do the whole darn thing as you go. So the first thing we usually do is we look for the equivalent resistance. So I'm going to take some sticky notes. And the first thing I'm going to do is combine these two resistors in series because I can. So those two are completely series. When I cover them up, then that's a 4 and a 7 and a 4 and a 7 add directly because they're in series. So that will replace with a single resistor that for me is going to be 4 plus 7 equals 11. So I'm going to get an 11 ohm resistor there. The next thing I can do is this one and this one will be parallel to each other. So I've got an 11 and a 5. So I'm going to replace those with a single resistor. And those 11 and 5, I'm going to cover up everything from there to there and replace them with a single resistor right here. And what that's going to be is it's going to be this 11 and this 5. So it's going to be 1 over that R, I'm going to call that R2, equals 1 over 5 plus 1 over 11. So 1/5 plus 1/11, find the answer to that. Do 1 over that to get my R2. So now I've got this, which I call R2. Now I've got a 10 and a 10 here. Well, those are in parallel to one another, so I can cover them up and replace them. I'm going to move this over a little bit. I'm going to replace them with a single resistor. And I happen to know that 1 over 10 plus 1 over 10 is 2 over 10 is 1 over 5. So this is going to be a 5 ohm resistor, but I'll just call that R3. And so 1 over R3 is going to be 1 over 10 plus 1 over 10. So that's going to give me a 5 ohm resistor there. Now finally I have a battery, and I've got 1 resistor, 2 resistor, 3 resistors in series, so I can add all of those up. So my total resistance of this circuit, if I can leave the switch there, so my total resistance of the circuit, leaving my battery there, is going to be a single resistor, which is going to be what I had as R2 plus R3 plus 15. So this is going to be R2 plus R3 plus 15 is going to give me my equivalent resistance of the whole circuit. So now I'm going to have to work my way back up. So I might as well just learn everything and then work from there. So now I know the resistance, I know the voltage. If I know 12.4 volts and the resistance, I can find from the resistance and the voltage, I can find my current here. Well, if my current there is my current out of the battery, it's the current in that whole circuit. So that current is going to be the same as the current in all of these. So since I know that current, I can just say that's the current here. And that current is going to be the same throughout all of these. So now I know my current here, I know my current here, and I know my current here. So I'll call that I of the 15. Okay. Now, since I know my current here, well, if I know my current and my resistance here, I can figure out my voltage here. My voltage here will be the same as my voltage here. So I'll call that, if that's R3, then I'm going to use R and I to get V3. So that voltage, resistance, and current will be the same as here I'm going to have V3, and here I'm going to have V3 because these are parallel to each other. Here I've got R2 and I2, so I can get V2. If I've got V2, R2, and I2, V equals I times R, then I know that this one and this one are each on V2. So this has got V2, and this has got V2. If this is V and R, I can figure out I2 from these two. And this is V2, and this is an R, so I can figure out well, I'm going to figure out my I through the 5. I'll call that I5. And then I can figure out my current down this branch is going to be my current down this branch. If I know my current down this branch, then I know my current here and my current here, because these currents are going to equal this current. And now I know my current and my resistance, my current, my resistance, my current, my resistance. I know everything about this circuit. So now if I want my potential difference across the 4 ohm resistor, well, I know V equals that I times that R. If I want my potential difference across the 7 ohm resistor, well, that's an I and that's an R. If I want my potential difference across either of the 10 ohm resistors, well, I figured that out. That was already this V3. If I want the current in either one of the 10 ohm resistors, now I've got V and R, so I can get I. And if I want the potential difference across the 15 ohm resistor, that's my total current going to the battery, and my 15 ohm resistor, IR, will give me V. So I didn't do the numbers, but that's up to you to step through this, maybe pause a lot and see what you get.